Hello students and friends. So here we have a discussion on JEE Main September first shift and second shift problems, right, from only calculus. So in this video we are going to discuss the problems from the calculus. Okay. Now first problem is on limits. Here you can see limit x tends to 1 x plus x square plus x cube plus up to so on x to the power of n minus n by x minus 1 is equals to 820, and the value of n we have to find out. So here you can see, always what we have to do first, you substitute the x value directly into the function so that you will understand what we have to do. If you substitute x is equals to 1, here you can see 1 plus 1 plus 1. How many times you have this? X power 1 started with x power 1. So here we have n terms. So in these n terms, if you substitute x is equals to 1, it corresponds to 1 plus 1 plus 1 plus, it will be 1 plus 1 plus 1 n times. So you will get n here minus n. So n minus n is 0 by, here x value 1, if you put 1 minus 1 0. So 0 by 0 you are getting. So whenever you get 0 by 0, do you know, can you identify what is the method we use? L'Hopital rule. Whenever you have 0 by 0 or infinity by infinity, and some forms are there. For example, infinity minus infinity, it can be reduced into this form or this form, depend on the problem. But for these forms we use L'Hopital rule. What is a L'Hopital rule? Let me explain this. Limit x tends to a. So try to understand the concepts. F of x by g of x, if you have, you get these forms whenever you do the direct substitution. We will write this limit as limit x tends to a, derivative of the numerator function and derivative of the denominator function. Okay, so this is L'Hopital rule. So we can now do this problem by this method. Limit x tends to 1. So you have to differentiate the numerator. So x derivative is 1 plus x square derivative is 2x plus x cube derivative is 3x square. So plus up to so on x to the power of n derivative n into x to the power of n minus 1. And minus you have n derivative. N is a constant. Derivative of a constant is 0 divided by, what you have here, divided by x minus 1 derivative. X derivative is 1, 1 derivative is 0, which is given as 820. Now what we do here, once again you use the substitution method. If you substitute x is equals to 1, what you get here? 1 plus 2 plus 3 plus up to so on n. If you replace x by 1, you get this, which is equals to 820. So from this, n into, this is sum of first n natural numbers. So n into n plus 1 by 2. That is the formula you have. You know that sigma n is equals to n into n plus 1 by 2. Sum of first n natural numbers, which is equals to 820. So this implies you get n into n plus 1, which is equals to 1640. So you can solve using the quadratic equations, or simply you can check the options. Right, so here I didn't provide the options, so with the help of options you can solve this. Now the second problem from the limits, this is from shift 2, afternoon shift, afternoon session. So just now what I told you, first you substitute the value of x. To know the method, what method should be applied to solve this problem can be known by direct substitution. So now if you substitute directly, what happens? X is equals to 0. So it will become tan pi by 4. And you know the tan pi by 4 value is 1. And if you substitute x is equal to 0 in this place in power, what you will get here, if you substitute x equals to 0 here, you get 1 by 0, which is infinity. So it is going to be tends to 1 to the power of infinity form. Now for 1 to the power of infinity, we have a separate method. So let me explain that first. If you get 1 to the power of infinity, if your limit approaches to the form 1 to the power of infinity, which is indeterminate form, what we will do? So let me explain that method. Limit x tends to a, you have f of x to the power of g of x. And if it is forming 1 to the power of infinity, then what we do here, we write e to the power of limit x tends to a, bring this g of x down, g of x, and you subtract 1 from the base function, that is f of x minus 1. So this is the way of solving the limits which tends to the form 1 to the power of infinity. Right? So limit x tends to a, f of x to the power of g of x can be written as what? E to the power of exponential of limit x tends to a, bring the power function down, g of x, and you subtract 1 from the base function. This f of x is the base. So f of x minus 1. So here you know g of x, what is f of x here? F of x is tan of pi by 4 plus x, and g of x is your 1 by x. So now we solve the problem. So here we have the given limit is limit extends to a. First of all, what I do, tan of a plus b formula I will apply. Tan of a plus b, tan a plus tan b. So what do you get here? Tan pi by 4 is 1. So 1 plus tan x by 1 minus tan x to the power of 1 by x. This is the question. Now this can be written as e to the power of limit extends to a. Bring the power function down. So 1 by x into 1 plus tan x by 1 minus tan x, from which you have to subtract to 1. Right? So it's a standard method. This is equal to e to the power of limit extends to 0, 1 by x. So if you take LCM here, what is that? 1 minus tan x. What you get in the numerator? 1 plus tan x minus 1 plus tan x. So here minus 1 plus 1 cancel. E to the power of limit extends to 0. Can you see here we have tan x plus tan x, 2 tan x. I can write the 2 outside of limit, and the tan x together with this x I will write. So tan x by x, and I separate the limit for the remaining function. So limit extends to 0. What is remained in the denominator? 1 by 1 minus tan x. Now you can substitute x value 0. So e to the power of 2 into, this is the standard limit. Limit extends to 0. Tan x by x is 1. And here if you substitute x is equals to 0, tan 0 is 0. So 1 minus 0, 1, 1 by 1. So you get 2 into 1. So which is equals to e square. Now you see, this is the problem from maxima minima. Number of points of local maxima and minima of this function f of x is equals to minus 3 by 4x power 4 minus 8x cube minus 45 by 2x square plus 105 r. So the number of points of local maxima. So how many local maxima, how many local minima? Total we have to find out how many local maxima are there, local minima are there. So to find local maxima or local minima, what is the concept we have? Do you know what is that? So the local maxima or local minima must satisfy this condition f dash x is equals to 0, where the derivative vanishes. Where the derivative value becomes 0, there you may have a local maxima and local minima. So first we will find f dash x is equal to 0. We solve for x, then we will find out whether the point becomes a local minima or local maxima, or neither local maxima nor local minima, nor local minima. Yes, so first what we do here, we will find the derivative of the given function to know the stationary points. You know what is the stationary points? The points which satisfies f dash is equal to 0, f dash x equal to 0 are called stationary points. Right. So now what is the derivative? F dash x is equals to minus 3 by 4 into x power 4 derivative is 4x cube minus 8 into x cube derivative is 3x square minus 45 by 2 into x square derivative is 2x, and 105 is a constant whose derivative is 0. Now after simplification, 4 cancel, minus 3x cube, then here 8 3 is a 24x square, and 2 cancel, so minus 45x. I think is common in this. I think we can take minus 3 common. So we get x cube plus 8x square. I think x also can be taken common. We'll take next step, minus or plus. What do you have here? 3, 1, 5. So 15x. Now consider f dash x is equals to 0. Implies minus 3 is gone. We'll take x common. So we get x square plus 8x. What is that? Plus 15 is equals to 0. Now you can solve for x. One value of x is already 0. And if you factorize this, 5 3 is a 15, right? So x plus 3 is 0. X plus 3, you will get 0. And one more, you get x plus 5, which is 0. You can do this yourself. Quadratic equation. 5 3 is a 15. So 5x plus 3x. After writing that, and you get the factors x plus 3 and x plus 5. So x is equals to 0, and I have minus 3, minus 5. So I got 3 points which are stationary points. Now we don't know which is a local minima and which is a local maxima. Sometimes there may be neither local maxima nor local minima. Now what we do here, we find the sign scheme of this f dash x. We will find the sign scheme. right? So now you're seeing here you have 3 points. One is 0 and one is -3 and one more we have -5. So if you use the wavy curve method, I'm expecting that you know the wavy curve method, right? So here extreme right is plus, then we take minus, then we take plus, then we take minus here. So after 0 f dash x is positive. After 0 f dash x is positive, so it is more than 0. F dash x is positive means it is increasing function in this. Now in between -3 to 0 f dash is negative means it is decreasing function. You know the rules. F dash is positive means f is increasing greater than or equal to 0, and f dash is less than or equal to 0, less than 0, then f is what? Decreasing. This is the condition we have. So in between -5 to -3, it is what? Again increasing because of derivative is positive, and here we have decreasing. So if you see the graph how it goes, decreasing means from left it goes, see, let us suppose here we have -5, here we have -3, and here 0. So if you see the graph, the rough sketch, it goes down up to -5. After -5, it goes up because of in between -5 to -3 it is increasing. Then after -3, it decreases again up to some value, particular value. We don't know what is that value. I'm not interested to find that one now. 0, decreasing is completed now. After 0, it goes up again. Right. So now you can see this goes up continuously. Now you can see here we have local minima, here we have local minima, and here we have local maxima. So we have two local minima and one local maxima. What are the local minima points? -5 and 0. -5 and 0, these are two local minimas, and at -3 it is going to have local maxima. So total number of points, local maxima and local minima, is what? 3. Local maxima how many? Only one local maxima. How many local minima? Two local minima. So this is the, so it's one more problem from maxima minima. Here there are actually, you should have options for this question, because what we have to do is not there in the question what I wrote here. F of x is equals to ln 1 plus x by x. Here we have to decide the given function is increasing or decreasing. Right. To decide a function is increasing and decreasing, normally what we do, we find its derivative, and if the derivative is positive or non-negative, it is increasing. Just now I told you in the previous problem. So if f dash is negative or less than or equals to 0, then it is going to be decreasing. So this is the base idea for this problem. Okay, so first we start doing the differentiation of f of x. So f dash x is equals to u by v formula we will apply. So x square, and we'll have here x and log of 1 plus x base e, that is ln of 1 plus x derivative 1 by x minus ln 1 plus x or log 1 plus x I write, which is base e only, into x derivative is 1. So what you got here, f dash x is equals to, if you take 1 plus x LCM, what you get? X minus 1 plus x into log of 1 plus x divided by x square into 1 plus x. Now you see, it is here difficult to decide whether f dash x is positive or negative directly from this step. Now can you see, x square is already positive, right? And what about 1 plus x? Now you see, because of in the problem log of 1 plus x is given with the base e is defined. When it is defined, can you tell me when it is defined? Its domain, whenever 1 plus x is positive, means x should be greater than -1. So the domain of this problem is -1 comma infinity, which you know it is already mentioned in the problem. Why it is mentioned in the problem? Because of log of 1 plus x should be defined, means x should be more than -1. So if x is more than 1 minus 1, what is the meaning of that? 1 plus x is positive. So can you see 1 plus x is also positive. So he clearly, it is clear that the denominator is positive here. In f dash x, the denominator is positive. Now the problem is with the numerator. Now what about numerator? Numerator is positive or negative, that we have to decide. Now to decide this x minus of 1 plus x, log of 1 plus x, this function, a new function formed in the numerator, it is positive or negative, we have to decide now. So for that purpose, what we do, we define one more function g of x, which is sitting in the numerator. G of x is equals to x minus into 1 plus x log of 1 plus x. So to find the behavior of this function, once again we use the calculus. So first we differentiate this. So once again I repeat, denominator is positive, already we know, but we have to decide whether f dash x is positive or negative. So to decide this f dash x is positive or negative, denominator is already positive. So say for example numerator is also positive, then f dash x will become positive. If numerator is negative, then f dash x will become negative. So it is depend on whether numerator is positive or negative. So that's why we are going to find whether the numerator is positive or negative. So I defined a function g of x is equals to x minus 1 plus x into log of 1 plus x. So what we do here, we find now g dash x. So x derivative 1 minus, we use u into v here, 1 plus x. Now log of 1 plus x derivative is what? 1 by 1 plus x. Then we write minus log 1 plus x into 1 plus x derivative is 1. So which gives us 1 minus 1 cancels 0. So minus log of 1 plus x. Minus log of 1 plus x. Now minus log of 1 plus x. So this will become positive. This will become positive. What is that? G dash x, right? Positive. If what? Log of 1 plus x is negative. Now this will become negative. Try to understand this. If log of 1 plus x is positive, can you see here? If log of 1 plus x is negative, that minus into minus will become plus. So it will be positive. But if this is negative, this is negative, then minus into minus, it will become plus. So what I wrote here, it is negative, it is positive. And log of 1 plus x is positive, plus into minus, minus negative. Correct. Now you know, when log 1 plus x will be negative. When log 1 plus x will be negative. You know, the graph of log x, you know, whenever base is more than 1, this is the graph of log x, a rough graph, right? So this is 1. Before 1, log will take negative values, less than 1. If the input is less than 1, log takes negative value. So either input is 1 plus x. So if 1 plus x is less than 1, it takes negative values, means x is less than 0. So x is less than 0, but it should be more than minus 1. So therefore, for minus 1 to 0, this is, and this is for what? 0 to infinity. So for minus 1 to 0, so I'll write that the conclusion is g dash x will become positive. Okay, if it is negative, means if minus x belongs to minus 1 comma 0, and g dash x will become negative for x belongs to 0 to infinity. Now can you tell me, g dash x is positive means now we concentrate on the graph of g of x. Okay, so the domain is here what? Minus 1, 0, and it goes to infinity. Right, in between minus 1 to 0. Can you tell me, in between minus 1 to 0, g dash x is positive means it is increasing. It is increasing. Alright, so if you substitute x is equals to minus 1, can you substitute x equal to? It is not defined. But it goes up. As it is going from minus 1 to 0, it is goes up. So what is x is equals to 0, we will see now. If you substitute x is equals to 0 here, this will become 0, and 0, 1, and log 1, it will become 0. This will become 0. Right. So g dash x is positive, but it is increasing. It is increasing. So it goes like this. It is increasing. And it becomes 0, it is 0. And after that, what is happening here? Whenever it moves from 0 to infinity, means whenever it moves from 0 to right, g dash x is negative, means it decreases. So it decreases continuously. So what you formed here, maximum value of the function. The maximum value of the function is 0. So what is the meaning of this? G of x is always less than, this is the maximum, means g of x is always less than 0, which is negative. So g of x is negative always. Can you see the graph? It is below, if I say this is x-axis, is below x-axis the graph. Okay, so therefore g of x is always negative. Now come to this f dash x. Now the numerator, this is our numerator, g of x. Numerator I considered as g of x. Now the numerator, what I got the result is the numerator is negative, whereas denominator is positive. So negative by positive, what you have? Negative by positive. So f dash x is negative. So f dash x is negative means f is decreasing. In what interval it is decreasing? Because of g of x is negative in this domain minus 1 comma infinity. In this domain, g is negative. So therefore on this domain f dash x is negative. So in the given domain the f of x is decreasing function. So therefore f of decreases always. So this is from maxima minima. Two questions from maxima minima First one is from shift 1 and the second one is from shift 2. So this is the problem from areas. We have to find out area enclosed by the region mod x by 2 plus mod y by 3 is greater than or equals to 1, and x square by 4 plus y square by 9 is less than or equals to 1. So if you identify this, it is in the form of x square by a square plus y square by b square is equals to 1. So here a square is equals to 2 and b square is equals to 9. So therefore a is equals to 2 and b is equals to 3. Right. So the first we will draw the ellipse now. So this is the ellipse, right, where a value is 2 and b value is 3. So these are the numbers we have: minus 2 to 2 and minus 3 to 3. A value is 2 and b value is 3. Okay. Now what is the second one? The second one is mod x by 2 plus mod y by 3 is greater than or equals to 1. Actually what it is, what is the curve, what is the type of the curve it is? Now this is equation of a line. If I take, instead of that greater than or equals to 1, if I write simply is equals to mod x by 2 plus mod y by 3, which is equals to 1. Now first you consider x comma y both are positive. If I take x comma y both are positive, you get x by 2 plus y by 3 is equals to 1. What is this? You know, it's an equation of a line whose x intercept is 2 and y intercept is 3. So if you draw this line, like this, x intercept is 2 and y intercept is 3. Okay, now if xy positive, this is the line segment you are going to get. It is in the only first quadrant, because if x is positive, y is positive, means it is in the first quadrant. So you get a line segment. You are not going to get a line like this, just line segment. So similarly, if you take x is negative and y is positive, then we get the line like this. And if you take x is positive and y is negative, then we get the line like this. So there are four possibilities: that x positive, y positive, x positive, y negative, x negative, y positive, x negative, y negative. So this is the line. Now greater than or equals to 1 means what? Greater than or equal to means outside of this. Okay, so where is the area formed actually? What is the region for which the area is required? You know, inside the ellipse, less than or equal to mean inside the ellipse and outside this. Okay, so now how to do that? What is the area? Can you see here? This is the area in all four parts, all four quadrants. So this is the area we have to find out. Now how we will find out this? Now you see, this is the symmetric curves. The ellipse is symmetric about x-axis as well as symmetric about y-axis, the ellipse. So what I do first, I will find out area of the ellipse, area of the total ellipse. What is the formula to find out area of the total ellipse? Is pi ab, where here pi ab, where a value is 2 and b value is 3. If you substitute 2 3 is 6 pi, you are going to get this is area of the ellipse. So due to symmetry, this portion, the first quadrant area, is 1/4 of the total area. So I will write that 1/4 of 6 pi. Later I will write this area. So here to here, this is the 1/4 of the ellipse area. So say this is something area, let us suppose capital A. So capital A is equals to, or capital A1 is equals to, how much I got? 1/4 of 6 pi, which is 3 pi by 2. Now next what I do, now I will find this area, which is below this line, below the line x by 2 plus this is the triangle, right? For this triangle, base is 2 units, we know this is 2 units, and height is 3 units. So say that is the area 2. That is the area 2, A2, which is equal to area of the triangle half into base into height. How much it is? 3 square units. Now from this A1, so the A1 I told this area, from this A1, if you remove the area of this triangle, what you are going to get? You are going to get this area. This is the area you are going to get. Right, so that is something, say capital A. So capital A is equals to area of the ellipse 3 pi by 2 A1 value minus A2 if you subtract. So this is 3 pi minus 6 divided by 2. So now the required area is equals to what? 4 times of this area, because of the same area is here we have, and the same area here we have, and the same area here we have. So therefore 4 times of this A, that is 3 pi minus 6 by 2. which is 2 to the 4, we get 6 pi minus 12 square units. Next problem on area from the shift to actual, it is if y is equals to alpha, bisects the area bounded by the region bounded by region given by x square is less than or equal to y is less than or equals to 2x. So if you split this, you will have two curves. One is x square is equals to y given, and the other is y is equals to 2x. So in between these two, x square and 2x, in between the curves, bounded by these two curves, y is equal to x square, you know this is the parabola, and y is equal to 2x is a straight line passing through the origin, right? So in between them you have an area, and that area is bisected by y is equals to alpha. Now can you tell me y is equals to alpha is again a straight line. This is also a straight line parallel to x-axis. Y is equal to alpha is a line parallel to x-axis. Now let me draw the picture first. Let me draw the graph first. So here we have a coordinate system, and here we have y is equals to x square and the line y is equals to 2x. Okay, now here we have to find out the area between these two curves. So where is we have that area? Here we have that area. So this is the area for which we have to find, this is the region for which we have to find out the area. Now to do this, and that area is bisected by y is equals to alpha. Now let me draw the line y is equals to alpha. So let us suppose somewhere I have a line y is equals to alpha like this. The line y is equal to alpha is parallel to x-axis. So the area is bisected by this line. So y is equals to alpha bisects this area. Now how to do this? First we will find this point of intersection. This point we know the point of intersection, which is origin. Now we will find this point of intersection. So to find point of intersection, we have to solve these two equations. So x square is equals to y, and the another equation is y is equals to 2x. So equate them. So 2x is equals to x square you get. One is x equals to 0, already we know. So cancelling x on both sides, you get x is equals to 2. So x value is 2. If you substitute x value 2 in any one of these equations, you get 4. So now here the total area we can find out in any method, means using y values or using x values. If you want to find out area, what we can do, you have to integrate from 0 to, what is that here, this point is what, x is equals to 2, and what is this point here we have, this is 4. So you can find out this area, okay, the shaded region area, integration 0 to 2, upper curve minus lower curve, okay, that we can do. So we will get this area. But whenever you want to find this area, half of this area, here we cannot use, because of, if we use that x coordinates, there will be a problem. There will be a problem here. So instead of that, if you use y values, so if you write integration from 0 to alpha, right curve minus left curve. So whenever you use y coordinates in finding areas, you should write function in terms of y. Okay, so that I am going to do here. So total area is how much? Total area is how much here? Integration using y limits 0 to 4. Integration 0 to 4. Right curve is what here? Right curve is a parabola. You can see right side here we have the right side curve is parabola, and the left side curve is the line. So right side curve as a parabola, you should write in terms of y, because of we are using the limits of y, you should write the function in terms of y. What is the parabola equation? X square is equals to y. Then what is x is equals to root y. So that is the function we are using, root y minus left curve. What is the left curve? Line. So line equation is y is equals to 2x, but x is equals to what? Y by 2. So this is dy. This is the total area, but this area is double of this area. How to write that area? Using the integration. This is from integration what? 0 to alpha. So integration 0 to alpha, again right curve minus left curve, the same thing, root y minus y by 2 dy. Double of this is the total area, because of these two areas are equal. This area and this area are equal because of y is equal to alpha bisecting the region. Now just you have to simplify this to get the answer. So I wrote just the key of the problem, 8 alpha to the power of 3 by 2 minus 3 alpha square is equals to 8. So now root y integration is y to the power of 1 by 2 plus 1 by 1 by 2 plus 1, that is 3 by 2. So 2 by 3 y to the power of 3 by 2, limits are 0 to 4 minus half, then y square by 2, so y square is 0 to 4, which is equals to 2, same integration again, 2 by 3 y to the power of 3 by 2, 0 to alpha, okay, then minus 1 by 4 you get y square 0 to alpha. So if you simplify, somehow you are going to get the result, required result. So 2 by 3, if you substitute 4 here, 4 square, 2 square, 2 cancel, 2 cube 8 you get, because if you substitute 4, what do you get here? 4 to the power of 3 by 2, that is 2 cube to the power of 3 by 2, 2 square to the power of 3 by 2, which is what? 2 cube 8. So if you substitute 0, you are going to get 0. So 2 by 3 into 8 minus 1 by 4 into 4 square 16, which is equals to double of 2 by 3 alpha to the power of 3 by 2 minus 1 by 4 into alpha square. So here to the 16 by 3 minus 4, which is equals to, you can write to the 4 by 3 alpha to the power of 3 by 2 minus half alpha square. Okay, so you simplify this, you will get this. So now we see the next problem from the calculus. This is the problem from the definite integral. Integration 0 to 2 modulus of x minus 1 minus x. Now whenever you have dealing this type of problems, whenever modulus included in the problem, right, you can solve that by removing a modulus. So how to remove the modulus? Here you have to split the integral. Now think about this mod x. Mod x is x if x is positive, mod x is minus x if x is negative. Okay, so whenever x minus 1 is negative, what is the meaning of x minus 1 is negative? X is less than 1. So therefore we split this given integral before 1 and after 1. So integration 0 to 1, what is that? X minus 1 will become negative, so therefore it will become modulus of x minus 1 is equals to minus x minus 1. That is nothing but minus x plus 1. So we write that minus x plus 1, and after that you have minus x, 0 to 1. Then we have 1 to 2. So here we have the integration from 0 to 2. So we are splitting this at 1, 0 to 1, 1 integration, 0, 1 to 2. In 1 to 2, x minus 1 is what? More than 1 means x minus 1 is positive. X minus 1 is positive means modulus of x minus 1 will become x minus 1. So x minus 1 minus x dx. So after this integration 0 to 1 modulus of, what do we have here? 1 minus 2x. Inside modulus you can write 1 minus 2x, or you can write 2x minus 1 dx, plus integration 1 to 2, minus x plus x cancel, modulus of minus 1 is 1, so 1 dx. Now here once again we have a modulus, so once again you have to split this integral. So if 2x minus 1 is positive, what is the meaning of this 2x minus 1 is positive? X is greater than 1 by 2. So we have to split this integral 0 to 1 you have to split this at 1 by 2. 0 to half, 1 integration, half to 1 another integration. So this is equals to integration 0 to half. In between 0 to half means x value is less than half. X value is less than half means 2x minus 1 is negative. 2x minus 1 is negative means minus of 2x minus 1, that is minus 2x plus 1 dx. Then from half to 1, in this interval x is more than half means 2x minus 1 is positive. So here we'll have 2x minus 1 dx. మొత్తం సైలెంట్లో పెట్టు ఫోన్. ఎవరు చేస్తారు? మొత్తం సైలెంట్లో పెట్టు. Plus integration of 1 dx. Here we have x from 1 to 2. So now you can do the integration. Minus 2x, integration is x square by 2, 2 to cancel, so minus x square plus 1 dx is x, 0 to half, plus 2x minus 1 integration is again x square minus x half to 1. Then here we have substitute the limits, 2 minus 1, which is 1. So here if you substitute the limits again, minus 1 by 4 plus 1 by 2. If you substitute lower limit you will get 0, plus upper limit is 1 minus 1, then minus lower limit is 1 by 4 minus 1 by 2 plus 1. So here we have minus 1 by 4 minus 1 by 4 minus 2 by 4, which is minus 1 by 2, plus 1 by 2 plus 1 by 2, which is 1, and one more 1 here we have. So which is 2 minus half, 3 by 2. Another problem from definite integral based on modulus as well as the greatest integer function. So integration 1 to 2. What we do here, modulus of 2x minus. Now the definition of fractional part of x we are going to use. You can continue with bracket also, but it will take some time. So we are trying to solve little bit some less number of steps. So fractional part of x definition, you know, x minus of bracket x. So from this, what is bracket x? Greatest integer function is equals to x minus fractional part of x. So bracket of 3x will be 3x minus fractional part of 3x dx. So now this is equals to integration 1 to 2 modulus. What do you get here? 2x minus 3x minus x minus of minus plus 3x. So fractional part of 3x then minus x dx. So now you see inside mod, what you are seeing here, x value takes from 1 to 2. This is 1 to 2. Now it's a fractional part. Fractional part is always lies between 0 to 1. So this is smaller comparing with this x, because of x is taking from values from 1 to 2, whereas 3x is a fractional part of 3x is a value between 0 to 1. So therefore the function sitting inside the modulus is negative. So therefore you can remove that modulus now. Because of it is negative, you will get minus of this. Minus of this means x minus fractional part of 3x dx. This is equals to, I can separate the integral now, 1 to 2 x dx, which is a very simple integration. Now in this integration 1 to 2 3x, what I do, I'll suppose 3x is equals to t. Then what happens? Dx is equals to 1 by 3 dt. So I write here 1 by 3 integration of dt, and 3x what we supposed here, t. So fractional part of t dt, and here the intervals you have to change. Whenever you substitute 3x is equals to t, x is equals to 1, it will become 3, this will become 6. Now you see, I am going to use one formula, integration 0 to n fractional part of x dx is n by 2. Okay, integration 0 to n fractional part of x dx is always equals to n by 2. Now what I do here, integration 3 to 6, I can write like this, integration 0 to 6, from which I will subtract 0 to 3. Here we have c 0 3 6. We want integration from 3 to 6. So find integration from 0 to 6, from which you subtract 0 to 3. So you get 3 to 6. Now, so this is equals to x square by 2, 1 to 2 minus 1 by 3. So first integration 0 to 6. According to this formula, integration 0 to 6, 6 by 2. That is 6 by 2 minus integration 0 to 3. 0 to 3, if you have 0 to n, n by 2. So 0 to 3, 3 by 2 for a fractional part of t. So if you calculate 4 square minus 1 square, 3 by 2 minus 6 minus 3 by 2, 3 by 2, 3 3 cancel, 1 by 2. So 3 by 2 minus 1 by 2, which is equals to 1. Okay, so I used this. If you want, you can prove yourself. This is very simple to prove. Dx is equals to n by 2. This is the formula I used. Now you see problem number 9. If 1 plus, this is a question from the differential equations calculus. What is given here? 1 plus sin x into dy is equals to minus of 1 plus y into cos x dx. So can you see, it is clearly given in variable separable method, right? So you can separate the variables here. 1 plus y we write with dy, and is equals to minus cos x by 1 plus sin x dx. So variables are separated. So after separation of the variables, what we do? We integrate to find out the solution. So integration of, I'll bring this term this side. So I'll write first x term cos x by 1 plus sin x dx plus what you have, integration 1 by 1 plus y dy. So because of both integrals are going to be in terms of log, so I'll use log c. So you see here 1 plus sin x, its derivative is cos x, because the one derivative is 0, sin x derivative is cos x. So f dash x by f of x form. F dash x by f of x is log mod f of x. So log mod 1 plus sin x plus integration 1 by 1 plus y is log mod 1 plus y, which is equals to log c. So using logarithmic rules and removing log, at the end you get 1 plus y into 1 plus sin x, 1 plus y into 1 plus sin x, which is equals to c. But you see here, y of 0 is equals to 1. You can use this condition, initial condition, to get the c value. So put x equals to 0 and y is equals to 1. So y is equal to 1 plus 1, 2 into x equal to 0. Sin 0 is 0, so you get 1 here, which is c. So we got the value of c. Now after getting the value of c, we write the function now 1 plus y into, or you can write 1 plus y is equals to 2 by 1 plus sin x. And what is y then? Y is equals to 2 by 1 plus sin x minus 1. Now here we have to find out a value. What is a value? Y of pi, means you substitute x is equals to pi here. So if you substitute x is equals to pi, 2 by 1 plus sin pi is 0 minus 1, which is 2 minus 1. So this is the value of a. Now how b is defined? Derivative at x equals to pi. So first you find derivative, dy by dx is equals to 1 by x derivative, 2 into 1 by x derivative minus 1 by x square. So minus 1 by 1 plus sin x whole square. I suppose here x, okay, 1 by x derivative minus 1 by x square into chain rule, 1 plus sin x derivative again cos x minus 1 derivative 0, so leave it. Now x is equals to pi, you substitute to get the value of b. So minus 2 by, again x equal to pi 0, so 1 square you get, and here cos pi is minus 1. So we get at the end plus 2. So b value is plus 2, a value is plus 1. So a comma b is 1 comma 2. So the problem from calculus, differential equations. So we write first dy by dx. Dy by dx is equals to 2xy plus y square by 2x square. So here you can solve this I think in two methods. One is homogeneous differential equation and the another is linear differential equation. In two methods we can solve this. So I'll show you how to solve this with homogeneous differential equation. Right, so whenever you know that given differential equation in the form of homogeneous differential equation, simply we put y is equal to xv and we write dy by dx is equal to x into dv by dx plus v. So substitute here, we get x into dv by dx plus v, which is equals to what you get here. I'll write directly, right, by putting y value v and x value 1, it is nothing but substituting y is equal to xv and simplification will be done directly. Okay, so we get this one 2v plus v square by 2. This is we are going to get. Now this implies x into dv by dx is equals to 2v plus v square by 2 minus v. Okay, so if you take 2 LCM, you will get minus 2v plus 2v will be cancelled. Remained is v square by 2. So now variable separable method 2 by v square dv is equals to 1 by x dx. Now if you integrate this on both sides, what is the integration of 1 by x square integration? You know, integration of 1 by x square is minus 1 by x. So integration of 1 by v square is minus 1 by v. So minus 2 by v. 1 by x integration is log x plus c. Now what is v actually from this? V is equal to y by x. So minus, if you write v y by x, it will be reversed. So minus 2x by y, which is equals to log x plus c. Now the differential equation is solved. Now after that, the initial condition is 1 comma 2, means x value is 1 and y value is 2. You substitute here. So minus 2 into x value is 1, y value is 2, log x value is 1 plus c log 1 is 0. So you get c is equals to minus 1. So copy that value. Minus 2x by y is equals to log x and c value is minus 1. You take minus on both sides and you write y value. What is y value from this? 2x by, you get 1 minus log x after taking minus common. Now we want the value at x equals to 1 by 2. So if you substitute x is equals to 1 by 2, 2 into 1 by 2 by 1 minus log 1 by 2. So here 2 cancel, you get 1 by log 1 by 2, log a minus log b, log 1 is 0. So you get 1 plus log 2. So the same problem you can solve using a linear differential equation in the Bernoulli form. Now the problem number 11 from the calculus, which is finding equation of the normal, tangents and normals concept. How to find out equation of a normal? So we need to find first the slope of a normal, and the point is given here. So slope point we use and we will find out equation of the normal, slope point form. For that we need slope. What is the point? Point is x equals to 0. If you substitute x is equals to 0, y is equals to 1 plus 0 is 1 to the power of 2y plus, here we get sin inverse 0. What is sin inverse 0? 0. Cos 0 is 1. So you get 1. 1 plus 1 is 2. So the point is 0 comma 2. At this point we have to find out equation of the normal. So now we have to find out the slope of the normal. To find slope of the normal, we have to differentiate from which we get slope of a tangent and from which you can get slope of a normal. So now how to differentiate this variable to the power of variable if you have. See, if you want to find out x to the power of x derivative, generally what we do, we apply log on both sides and we differentiate. Instead of that, x to the power of x, simply you can write e to the power of log x to the power of x. Because of e log will be cancelled. E log x is x only, right? So using this technique we can write e log x to the power of x, so which is nothing but e x log x. So the same technique we use here. Y is equals to e to the power of, what we write, 2y into log of 1 plus x, right? Because of e to the power of log x is x, so we used this. Then plus cos square of sine inverse x. Now what we do here, cos square theta is what, 1 minus sine square theta, so that is sine theta whole square. If you write that, 1 minus sine theta, what is theta here, sine inverse x whole square, sorry, so this whole square, right? So y is equals to e to the power of 2y log of 1 plus x plus 1 minus sine of sine inverse x is x, so x square. Now we differentiate dy by dx. So dy by dx is equals to y dash, will write e to the power of x derivative e to the power of x, so e to the power of 2y log 1 plus x into chain rule, this into this, u into v. So 2y log of 1 plus x derivative 1 by 1 plus x plus log of 1 plus x we leave as it is, and 2y derivative is 2 into y dash. Okay, so the differentiation of this is finished. Now derivative of 1 is 0 minus derivative of x square is 2x. So this implies y dash is equal to, I replace this again in the original function, 1 plus x to the power of 2y, actually it is, we written alternative form to differentiate, right? So 2y by 1 plus x plus 2 log 1 plus x into y dash. Actually we want the derivative value at x equals to 0, but whenever x is equals to 0 you can keep y equals to 2. So substitute all these values in this. So y dash is equal to x is equal to, it will become 1, leave it, and y is equals to 2 to the 4, 4 by 1, so that is 4 plus 2, x equals to 0, so it will become 1 plus 0 log 1, log 1 is 0, so it will become 0 into y dash minus 2x, 2x means 2, 0. So what is y dash value here? So here we got y dash is 4, means slope of the tangent line at the given point is 4. Then what is the slope of the normal? Slope of the normal is minus 1 by 4. So this is slope of the normal minus 1 by 4, and we know the point is 0 comma 2, so slope point form. So you can find using the slope point form. So to that, y minus y1, okay, is equals to m into x minus x1. So if you simplify this, x plus 4y minus 8 is equals to 0, you get x plus 4y minus 8 equals to 0. Okay, so here little bit differentiation part is lengthy, but here this is the technique, at least you have to use e to the power of log x is equals to x to differentiate a function which is in the form of variable to the power of the variable, any variable in terms of x or in terms of y. See, otherwise you have to take this function separately. You have to suppose this as something, say g. We have to find out dg by dx by applying log on both sides. Then you have to come back to replace the derivative here. Otherwise, this is the technique you can use. Okay. Now let me see one more problem from the calculus, and this is the last problem from the calculus part of JEE Main 2020 September 2nd, shift 1 and shift 2. These are the problems given in shift 1 and shift 2. So here you see p of x is a polynomial of degree 3. So it's a polynomial of degree 3, so which has maximum value 8 at x equals to 1 and minimum value 6 at x equals to 2. Sorry. And we have to find out the value of p of 0. Now you see, x is equal to 1 is a point of local maxima or maxima, and x is equals to 2 is a point of minima. So at local maxima or at local minima, what happens? Maxima or minima, local maxima or local minima, what happens? The polynomial derivative value will become 0. Means x minus 1 and x minus 2 are the factors of the derivative. So therefore we can write P of x is equals to, because we are x minus 1 and x minus 2 are factors, we can write x minus 1 into x minus 2, and we don't know the coefficient. Say the coefficient is something, say a. This is the p dash x, not p of x. A into x minus 1 into x minus 2. Now can we integrate this? Yes. By integrating this we get p of x. So integration of p dash x is p of x, which is equals to, so first of all we'll write this one, simplify first, x square minus 3x plus 2. Now integration is easy now. So a into integration of x square is x cube by 3 minus 3x square by 2 plus 2x. Now whenever you do the integration, you have to introduce a arbitrary constant plus b. Now we got the polynomial p of x, but the problem is we don't know the values of a comma b. But here you know at x equals to 1, p of x value is 8. So p of 1 is equals to 8. And one more, at x equals to 2, function value is 6. So p of 2 is equal to 6. You can use these two conditions to get the values of a comma b. So first of all I use this one, p of 1 is equal to 8, means x is equals to 1 if you substitute, a into 1 by 3 minus 3 by 2 if you substitute x is equals to 1, plus 2 plus b, which is equal to how much? 8. Right. So a into, if you take 6 LCM, how much you get here? 3 2s are 2 3s are plus 6 2s are plus b, which is equals to 8. So 12 minus 9 is 3, 3 plus 2 is 5. So 5a by 6 plus b is equals to 8. Now similarly, if you use this condition, p of 2 is equals to 6. If you use this condition, p of 2 is equals to 6, what you are going to get? X equals to 2, if you substitute, a into 2 cube is 8 by 3 minus 2 square, 4 by 2 is 2, so 6, plus again here 2 2s are 4. Okay, plus b is equal to how much? The value at 2 is 6. A into 8 by 3 minus 2, 2a by 3 plus b. From this, what is the b value? 8 minus 5a by 6, which is equals to 6. So if we take 6 LCM for these two, what do you get? 3 4a minus 5a, which is equals to 6 minus 8. So minus a by 6 is equal to minus 2, which implies a is equals to 12. So if you substitute back that a is equals to 12 here, 5 into 12 by 6 plus b is equals to 8. So 6 to the 12, 5 to the 10, so b is equal to 8 minus 10 minus 2. So we got b value also. So therefore at the end we have now with us p of x. What is p of x? Here we have p of x. A is how much? 12 into 12 into x cube by 3 minus 3x square by 2 plus 2x plus b. What is b here? Minus 2. Now he is asking p of 0. If you put x equals to 0 in this, you get the final answer, what? Minus 2, because of this becomes 0. If you substitute x equals 0, this becomes 0. So the value will be, p of 0 will be minus 2. So these are the problems from JEE Main 2020 September 2nd, the shift 1 and shift 2 calculus problems. Okay.